Alright, welcome back to the Mickey Mouse class. Today we'll be continuing our LCM series. In our last class we looked at finding LCM by listing multiples. Today we'll be looking at finding LCM by using the prime factorization method. Alright, if you don't know how to solve prime factorization or expressing a number as a product of its prime factors, you can check out our series on prime factorization. Okay, let's take an example. You can be asked to find the LCM of, let's say, 28 and 42. Now, the first thing, before I could find the LCM, the first thing I need to do is to express these numbers as product of its prime factors. So 28 is the same thing as 2 times 2 times 7. 2 times 2, 4. 4 times 7, 28. Now, the next one, 42, is the same thing as 2 times 3 times 7. I've ended up writing 42 as product of its prime factor. Now, I will not end there. I will put them in index form. Now, this is the same thing as, because how many 2 am I saying here? 2. I can write it as 2 raised to power 2 times 7. Now, here there's no, the 2 here appears only once, the 3 here appears only once, the 7, so no need. Now, you have 2 here, you have 2 here. Which one has the biggest power? So LCM, you select the one that has the biggest power. This is 2 raised to power 2, so I pick it out. 2 raised to power 2 times, this is 3, there's no 3 here, so I pick out 3 here, times 3, and the 2 7 have just one, they are raised to power 1. 1 7 here, 1 7 here, so I just pick out 1. So the LCM becomes 2 times 2, that's 4. 4 times 3, that's 12. 12 times 7, that is 84. So the LCM, the lowest common multiple of 28 and 42 is 84. That means that's the smallest number that 28 and 42 can both divide. All right, let's look at example 2. You can be asked to find the LCM of more than 2 numbers, probably, let's say, of 5, 10, and 15. So we are still using the prime factorization method. So you put 5 can be, you just want 5. Now 10 is the same thing as 2 times 5. Now 15 is the same thing as 3 times 5. Now the LCM, I can find 2 here, so I pick it out. There's no 2 here, there's no 2 here, so we cannot compare which one is bigger. So I just choose it. The same thing, there's 3 here, there's no 3 here, so I cannot compare. I just pick this one here, times 3. And the 5s that are there, all of them are raised to the power of 1. So I just pick it out. Now, so the LCM becomes 2 times 3, that's 6. 6 times 5, that's 30. So the LCM of 5, 10, and 15 is 30. That's the smallest number that the 3 numbers can divide. Okay, let's take the last example for today. Find the LCM of 12 and 18. So the first thing, of course, using the prime factorization method, 12 can be expressed as a product of its prime factor as 2 times 2 times 3. Now 18 can be expressed as 2 times 3 times 3. Now, let's put them in powers or in index form. I mean 2 am I using here? 2. So I can write it as 2 raised to power 2 times 3. Now here, I'm only seeing 1, 2. So that's 2 times, 3 am I using here? 3. Sorry, 2. That's 3 raised to power 2. Now, I have 2 raised to power 2 here. I have 2 raised to power 1. Which one has the biggest power? This one here. So I pick it out. So the LCM will be equal to 2 raised to power 2. Now, between these two, which one has the biggest power? This. So I pick it out, 3 raised to power 2. So the LCM is 2 raised to power 2 is 4. 3 raised to power 2 is 9. So 4 times 9 is 36. So the LCM of 12 and 18 is 36. Okay, I hope you have enjoyed today's class. Before we go, let's take home, like our usual style, take home fun. You can practice it at your leisure time. Find the LCM. Find the LCM of the first one, 6 and 15. The second one, you could have 30, 60, and 90. Remember, using Prime Factorization method. Okay, do let me know any area of mathematics you are having difficulty. You can put it in the comment section. Any topic you want me to treat, put it in the comment section. If you're having a question, 1 or 2 questions, even on this series, let me know. Until we meet again, have a blessed time. Bye.